All right, good evening or good morning or good afternoon. This is the second video. Um, this is based on chapter 8, and that's developing addition and subtraction or developing meanings behind the operations. So let's begin. Share my screen. Screen share. Let's go here. I made sure this time that my mute button is, uh, I'm not muted, so you can should hear me. All right, so let me do the slideshow from the beginning this time. This this is based on the 11th edition, although the 10th edition does have the same chapter, which is chapter 8, developing meaning for the operations. And so here are learning outcomes. We'll develop students' skills in generalizing the problem structure with additives situations involving joining, separating, part, whole, and comparisons where the unknown can be in any position. 8.2 explain how to teach meaning of the operations of addition, subtraction. Point 8.3 develop student skills of generalizing problem structures with multiplicative situations involving equal groups, comparison area, arrays where the unknown can be in any position. Again, explain how to teach the meaning of operations of multiplication and division and develop methods for helping students solve word problems. All right. So we start off with the first one, which is developing addition and subtraction problem structures. Um, and the last thing were the big ideas. So now we're going into developing addition and subtracting problem structures. Conceptual problems are the primary teaching tool. And what I mean by conceptual, that means word problems, situational problems. When you start that, and I'll start with just naked numbers. You incorporate problems that focus on strong visual support. Love that. Strong visual support. And remember now, visual support is part of contextual problems, part of those representations, those multiple representations. Remember the star that they have in the multiple representations that include visual, contextual, um, the physical, what are your manipulatives, the verbal when you're talking and discussing mathematics, and there's one more, the abstract. Yeah. So from an adult perspective, the idea of addition subtraction, for us as adults, it seems quite simple, but it's not for children. So look at this. Zoe had 7 beads. After she bought some more beads, she had 15 beads. How many beads did Zoe buy? Now, for us, we know it's just simple subtraction, but children, it's not that simple. So we have to model, our students have to model that action. That's what the book says. And it's true. They have to model that action so they can solve that problem. So let's look at these different levels of addition, subtraction, learning progression. Um, and I'm glad that they take the time to study these things so that our students will know, or we would know how our students develop. So we have small numbers, sums to 5. In fact, in kindergarten, that's what they go to 5. Then you find results plus and negative, minus, addition, subtraction, sums to 10 with the addition of part, whole with whole unknown. Then find change problems, addition of change unknown problems, and add to take from part whole. So you see how the progression is. So you don't start real difficult. Start off with those smaller numbers, and then you see the gradual progression. So I don't want to read all that to y'all. All right, so I really want you to copy this or write this out in your notebook because it's important. So in your notebook, I want you to um, mimic or stop your this slide. It's in your book as well, but stop the slide or stop the recording, and I want you to look at this and recreate this in your notebook. So we call this the change problem. And add to. Join and add to. So you have a start, and something goes to change the start and then you have some type of result. That's a physical action, a physical action. Results unknown. And this is Sandra and George. Sandra had 8 pennies. Okay, so we started off with 8 pennies. George gave her 4 more. So the change is you're gaining 4 more pennies. She gained 4 more pennies. How many pennies does Sandra have altogether? So that's 8 plus 4 equals some number. We know it's 12. Okay. Um, then we have change unknown, which is a physical action. Sandra has 8 pennies, right? She started off with 8 pennies. George gave her some. George gave her some. We don't know what George gave her, but he gave her some. Now Sandra has 12 pennies. How many did George give her? And you see where that middle is right here. The middle, the change is unknown here. Okay. And then the last one, start unknown. Sandra has some pennies. She started off with some pennies, right? George gave her 4 more. We don't know how much she started, but George gave her 4 more. Now Sandra has 12. How many pennies did Sandra have to begin with? So we have a start, we don't know, but we know the change is 4. Given change, given 4, we're changing things. And now we got 12. So we're looking at physical, some type of physical action is happening. Okay. And then we like my physical action here is not happening. Okay, here we go. So here is another physical problem, a physical action problem, but now we're talking about separation and take from. Separation and take from. Sounds like some subtraction stuff. So we start with something and then we're like doing something like giving something away or we're separating from it and then we have a result. Okay? And I want you to copy just like this. Okay? Result unknown. Sandra had 12 pennies. Start off with 12 pennies and she gave 4 to George. So she's actually giving some of them to George, giving 4 of them to George. How many pennies does Sandra have now? Okay. That's where we don't know the result. That we do is 8, but that's where the result is unknown. Then we have change unknown. Okay. Sandra has 12 pennies. She started off with 12 pennies. She giving some to George. We don't know. Now she has 8 pennies left. How many did she give to George? Okay. Then we have start unknown. Sandra had some pennies. She gave 4 to George. Now Sandra has 8 pennies left. How many pennies did Sandra have to begin with? See there, right here. That's where your start is unknown. Dr. Massey, we got to teach little kids this? Yes. In the state course of study, it starts as young as kindergarten with these different actions. Okay. But right here, this is a physical action that is happening. All right. Then we got part whole problems. And we visited that with early numeracy or early number concepts. So we have no physical action at all. Okay. Part, and then got the whole thing. All right. So we got whole unknown. George has 4 pennies and 8 nickels. How many coins does he have? Is there some action here happening? No. But we know we're joining some things together. Um, one part and another part, and you get a whole number. It's just like you're saying, George has 4 cookies, 4 sugar cookies, and 2 chocolate chip cookies. How many cookies does he have altogether? Right? How many cookies does he have? It's just like that. All right. You have 2 parts of a particular thing, and you got the whole thing. One part unknown. George has 12 coins. 8 of his coins are pennies, and the rest are nickels. How many nickels does George have? George have? So we have 12 coins, and we know 8 of his coins are pennies, and the rest are nickels. And I think they made an error here because it should be 8 right here, but okay. How many nickels does George have? Okay. And then we have both parts unknown. That's where it gets really kind of complicated. George has 12 pennies. Some are pennies and some are nickels. How many of each coin can he has? So you can have a variant part where both of the parts are unknown. And what you need to do is just come up with ways to make 12. Have students come up, not you, but have students come up with ways to make 12. So I want you to pause the video for a moment, and I want you to come up with these situations here where you have a change of physical actions happening, which is join and add to, where you're actually doing something or somebody's doing something to something. And then where there's no physical action, but these are parts of a particular whole, right? Okay. Most times we'll come up with the ones that have maybe some physical action or not, but students need to be able to come up or have experiences with the part whole relationship. All right, so now we got comparing problems, and comparing problems again have no action, but you're comparing finding the difference of two things. Okay, so you got this bigger amount right here, and then you have a smaller amount, and then there's a difference between the bigger amount and smaller amount. Situations of how many more. So when they say how many more has another, you're comparing. Okay, difference unknown. George has 12 pennies and Sandra has 8 pennies. How many more pennies does George have than Sandra? So you see that right here. You're comparing. One has that many, the other has that many. How many more one has than the other? Okay. Then you have larger quantity unknown. George has 4 more pennies than Sandra. Sandra has 8 pennies. How many pennies does George have? Okay. So George has 4 more pennies. 4 more pennies. That's something you can look at when we do praxis help. When you're translating these problems right here, or what they're talking about. So she started out with 8, and that's 4 more than 8, and you're trying to find out what that is. Then you have smaller quantity unknown. George has 4 more pennies than Sandra. George has 12 pennies. How many pennies does Sandra have? So that's when you're trying to figure out the smaller quantity. Okay. So I'll give you a chance to copy this in your notebook as well. Again, compare problems. There's no physical action going on. You're just comparing the two. The part whole problems, again, there's no physical action. You got two parts and a whole. But the change problem, there's a physical action. Okay. All right. So I want y'all to know the difference and how to teach those. All right. So with that being said, here's some problem difficulty that you may encounter. Joint and separate problems with start unknown. Join and separate problems with start unknown. Okay. It's hard for children to model with the start unknown because it's like algebra, which it is algebraic thinking rather. They don't know how many counts to put down initially. Okay. So you got to kind of walk them through that. You got to teach that. And there are some strategies here that where you have the joint and separate problems. The part whole problems. Here's some more problem difficulty with that. No action to model since it's conceptual bringing together of quantities. So there are some things that you can use, like for instance, they have the part whole mat you can use. You can also use what did you call, oh my goodness, oh, I want to say they're called cluster problems, but they're not called cluster problems. Oh, I gotta remember what they're called. But you'll have those type of problems. There are two things, and part whole problems that lend itself to that. Challenge for children is to grasp a quantity represents two things at once. So you got two things at once, and you can model that, but it's not like you can do an action. Compare problems. The challenge is the language. How many more one has than the other? So when somebody say how many more, initially they think of it as adding. However, when I say how many more one has than the other, then I'm comparing, and what leads to subtraction. So when teaching addition and subtraction, you guys, you start off with contextual problems. Start off with context, the problems, because and make it relevant to their lives. Okay, derive contextual problems from recent classroom experience, field trips, children's literature, art, science, social studies, something that relates to them, and have a discussion. Okay, so look at the problem they have here. Yesterday we measured how long you were using cubes. Well, that's something that happened in class. Dion and Rosa asked how many cubes long they are when they lie down head to foot. Rosa was 49 and a half cubes long, and Dion was 59 cubes long. How long are Rosa and Dion when lying head to foot? So think about that. Put it together, make it relevant to them. It could be something outside the classroom. It could be something inside the classroom. You could take daily data, and we do that a lot with daily data. We can take our data and come up with contextual problems to teach addition and subtraction. Part two, choosing numbers for word problems. And here, this is the structure. The structure of the problem you use will change the challenge. Okay. You can also vary the problem complexity by the numbers. So the more difficult the numbers are, the more challenging it's going to be. Numbers in the problem should align with the student's number development. So please don't give kindergartners, 3-digit numbers to subtract or add. No, don't do that to them. Use word problems as an opportunity for students to learn about number and computation simultaneously. So what does it mean to add? Giving them the meaning behind those numbers. Okay. Introduce symbols. Okay. Introduce symbols as ways to record what they did as they shared their thinking. So you are writing it out for them, and putting those symbols in that place. And let me see. Let me look back at here. Ooh, 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 ooh. My bad. You see how, I mean, these are older kids, of course, because you're 49 and a half inches in cubes. Uh, fourth grade buddy. My fourth grade buddy is 49-inch cubes. And then I know that I don't know what they were doing right here. 4 plus 5. Oh, yeah, the tens and so forth. And so they know that they have to add. Okay. But these are older kids. So you'll start with the younger kids, writing things out about what it means that we're adding things together and and taking things apart. Some care should be taken with the big idea of the equal sign, because it is a relational symbol meaning. So be careful not just to put the at the end. Okay. Because typically they say it's the equal sign means the answer. No, it means one side of the equation is relational to the other side of the equation, and they balance off. All grades should assess on the meaning of the equal sign. What did I say? All grades? All grades should assess. Yeah. I have a story. Trying to, keep it things short, but I have a story where I had students had a problem. They're fifth graders. They had a problem with the equal sign. They thought that putting the equal sign at the end means fine. The sentences, all sentences should look like that. All number sentences should look like that. So I found out that was their problem in one of our testing things. I think it was Global Scholar Scantron. And each one of them had that same problem. They had a misconception with the equal sign. So for a number talk I did, I put the equal sign in the front of the problem. So it was like just 10 equals 5 plus some number. And or 10 equals some number plus 8. I'm just making that up because I can't remember. That was years ago. And the student said, "You can't do that." And I said, "Why can't I put the equal sign there?" "Because the equal sign means find the answer." I said, "No, it doesn't." I said, "The equal sign means this side of the equation balances this side of the equation. So I'm saying 10 is some number plus that." And then that light bulb came on. So you got to think of the equal sign as that. Okay, representing addition and subtraction. Use concrete representation, y'all. The concrete. Teach addition and subtraction. They say teach it together. And sometimes you can. Well, most of the time you can. But for some strange reason, they kind of lose it. But look at what they're doing. Join or separate two bars of connecting cubes. So you got these connecting cubes right here, and then you can say joining. You put them together, and then separating or decomposing. You bring them apart. Okay, and that's showing them what it means to add and subtract. Join or separate using two colors, or you can get a part whole mat, which I mean, all it is you can get a sheet of paper, make a T chart, and put something at the top right here, and then put the parts. Okay. The book gives you several instance representations of addition and subtraction and how to teach it. And oh Lord, I wish we were having class. I could do that, but we will. Because if you don't understand, I will go back through this real quick. Addressing addition and subtraction on this is to this semi-concrete representation. Remember, I always start off with the concrete. Start off with cubes and counters and things that they can manipulate so that it can be meaningful, because they need the concrete before they go to the abstract. Concrete, model, abstract. And so there's your semi-concrete. They got a bar diagram. When the students get a little older, we know that you have the whole. I used to teach that when I taught Singapore math. I didn't teach math in Singapore, but that's a type of math. And you will have the whole, and then you'll have the parts, and then you have another part. And also making the parts relevant. So you see how this part right here and yellow, whatever color it is, orange, is bigger than the part in green. That's where you want the magnitude to show. Then you got number paths right here. Okay. Then the number line. Those are tools to use, you guys. So I want you to read about those. Representing addition and subtraction again. Abstract representation. So remember, you go concrete, semi-concrete, or the diagram, and then the abstract. Students should be translating the equation they see into concrete and semi-concrete representations, while also writing equations to match the situations they are modeling. So once I have my concrete, I draw it out, and then from my drawing I write the symbols so I can make those relationships. Then they will engage in thinking about problems with mental images and reasoning, while responding with more symbolic approaches. Look at that right there. And you see how they joining those. That's like a number talk to me, but yeah. Get my mind off number talk, y'all. So that, and usually what I usually do for this chapter is break the chapter up into, so you'll understand it. And I probably will, let me do that. Yeah. And stop right here. So I want to make sure you know that, remember when you're studying this, hold on, I'm gonna go back, that you know the concrete, you know the abstract, you know the different types of problems when it comes down to addition and subtraction. Multiplication and division, not as hard as the addition and subtraction, especially with the physical actions and the non-physical actions. I really want you to understand that and be able to make problems and related to this. So when you're drawing these things out, I want you to make your own problem, and it must be result unknown, change unknown, start unknown. And I want you to do the same thing for part whole relationships. Whole unknown, one part unknown, both part unknown. And we'll go on to the compare problems. I want you to do that. And then when we get back, or when I get back, then we'll go into the multiplication aspect. And then after that, we'll do place value. All right, y'all. I want to say happy homecoming, post homecoming. I'm so happy that we won. I can come up with a, yeah, you know what, you could come up with a yeah, you can come out with a part whole problem with the score. You sure could. Yes, you can. Yes, you can. Hmm. That's something to do. But I'm gonna let you come up with your own thing. Okay. All right. So I will see y'all next Monday. But I will give you. In fact, I really want to do a number talk with y'all so badly. It's just eating me up. So I may give you. I will give you one to do, um, and I want you to post your findings. Um, yeah, I think I am, and I'm gonna flash it. And I think I'm just gonna go back and do the um quick image with the 10 frames. But I want to do multiple 10 frames. All right. So I'll see y'all next week. I miss you guys. Um, couldn't help. I had to, I'm gonna do the calls. I got a 10. All right. See you later.